Hi everyone, let's start. We are going to talk about the pgwire protocol and how it drives the Postgres compatibility. To understand the context, look, on the market there are numerous of databases that claim that we are Postgres compatible. So we are going to understand what does it mean that some database says that I'm a Postgres compatible. Shortly about myself, I'm a former contributor at Picadata. It's an open source database, and what's more important, it also claims that it's Postgres compatible. Let's first talk what is pgwire. Pgwire is a protocol. What is protocol? Protocol is a formal set of rules that defines how client and server PostgreSQL communicate with each other. It includes the message that they send each other, message format, semantics, and etc. Also, pgwire is a TCP-based, bidirectional, and message-oriented binary protocol. On this diagram, you can see the basic flow of pgwire. If the client wants the encryption session, it always starts with SSL request, and the PostgreSQL server answers with 1 byte messages S or N, which is basically yes or no. And after that, TLS handshake happens. But if user wants a default session without encryption, there is it always starts with startup message. Startup message is important because it has the user's name, DB name that user wants to access, and others user's credentials and metadata. And what is also important to know is that when all of this data processed, the PostgreSQL server sends the ready for query signal, and only after that the clients can send queries to the server. Let's understand the structure of query message. It has the following scheme. First byte, it always defines the message type. The Q means query. There are also other types that defines other messages. There is always a length, which defines the length of the overall message in bytes. And the last one is a string, which it is basically a SQL text, like select something, your DDL or DML query that you're sending to the PostgreSQL server. So now let's understand what does it mean to be that some database claims that I'm a Postgres compatible. We should first define what is compatibility, what does it mean to be Postgres compatible. So there are Postgres compatibility levels. There are basically 4 levels, which defines the compatibility with Postgres. The first and foundational level is a wire protocol compatibility. It is done using pgwire. What it means that there are numerous databases on the market that implements the pgwire protocol, and it means that you can have a drop-in replacement of your PostgreSQL with this new database, and you save all your existing tools, scripts, and replace your Postgres with a more scalable database. Another level of compatibility is a syntax. Some databases implement same SQL, but some they extend the current PostgreSQL with their own custom. And there is another level, feature compatibility, which not many databases are eager to implement. It includes implement the system functions, the data types, backup, etc. And the last one which is mostly implemented on the Postgres forks. It's a runtime compatibility that will allow this custom database to run Postgres extensions like pgvector, pggis, pgcrypto, and it has the same system catalog. And here is the images that most databases, they're standing only on this wire protocol compatibility and don't go further, because it's very important and valued on the market. Here you can see the list of popular Postgres compatible databases. What is important that they all open sourced. You can check the sources on the GitHub. YugaByteDB and CockroachDB and Picadata, they all implement wire protocol compatibility. So you can certainly say that they Postgres compatible on the wire protocol. But if you go deeper to understand if they're compatible on the syntax level, the features level, or runtime, you will see a lot of differences. You will see that a lot of functions are not implemented, or the syntax like related to transactions are differ, or not differ, it's just extended with custom keywords. Here is the link where you can see the PostgreSQL derived databases. In this list, besides the Postgres compatible databases, you will see the Postgres forks, which basically is the same Postgres but with some custom changes. Let's check the example on the CockroachDB, how it really means, how it really helps to easily access the another database, but with the same tooling. We have the running instance of Cockroach here, and you see there are credentials to connect via web UI or via custom the CLI of that Cockroach implements. And there is also the third way to connect to the database instance is using Postgres, because Cockroach implements pgwire protocol, so you can connect to the CockroachDB instance same way with PSQL. Or if you use through your sources, you can use PsychoPG for Python, GDBC for Java, and libaq via C code. And you just run your code, run your queries. So simple. And what's more important, that the CockroachDB and YugaByteDB, Picadata I mentioned, they all distributed databases. It means one day you can hit your limits, your hardware limits, and you need to decide. You need either scale in or scale out, or you can simply switch to another database easily. It's a drop-in replacement because they implement pgwire protocol. The same way you can see that YugaByteDB, it has just slightly different interface, but the connection happens the same way. The YugaByteDB instance started here. It's a one instance only. There are credentials to connect via GDBC, via PSQL, and you just write them out here that you want to connect to your instance using PSQL, and it happens the same way. Since these projects are open source, you can see how they implement pgwire protocol by simply going through the sources. And that's it. Thank you for your attention, and we can have now Q&A session if you have some questions.
Yes, ask questions.
Yeah, more questions. More questions, please.
Cockroaches, right?
Yeah.
About the cockroaches.
You have a question?
No, and the database is called the cockroach.
Yeah.
You heard what it is?
No.
Taraka.
Ah.
You didn't know? That's what I'm saying. Just asking you about
No.
the cockroach.
Yeah, that's funny.
Okay.
Maybe,
No.
yeah.
About when I decide to don't use exactly Postgres, then I should use them.
When you hit your limit, for example, you have your application. It has,
For scale.
yeah, for scaling. The application has some front end and back end, and there is an instance where data is stored. It's executing on some machine, right? On some server or your laptop, for example. Your laptop has limits, your RAM, your disk space, and when you have a lot of data, a lot of clients, they use your app. A lot of data is saved on the hardware. Yeah, and you should always monitor that you don't hit the limit, because if you do, it means your app will crash. Yeah, and you just need to consider scaling always.
I have a question.
Yeah.
Why is that tool and not other open source?
Oh, that's a good question. Simply, they are very popular. And they are widely used in the industry.
And what are some of the use cases?
Use cases. uh, the famous use case when you have some service and you have clients in all over the world in different locations, so you distribute your data across all these locations. For example, one in Europe, one in US, one in Armenia. You can have 3 instances, and so data is easily accessed from US with lower latency. Since all data is distributed across all instances, people who want access it through US, if they are in US, they will access it with lower latency. But if you have all 3 instances in Armenia, the request will fly from US to Armenia. It's a lot of latency.
For that, we can use MongoDB, for example.
Yeah, if your data is not structured, MongoDB is NoSQL.
But when we want to distribute, we can, for example, choose MongoDB and we can solve this problem.
Yeah,
If our problem is only distributing.
But it's different structure.
for sure. It depends what type of data you have.
We can our data pass to document data.
Yeah, it can be. Can be.
One time I used MongoDB, and because when I learned database, it was with relational. It was with same as Postgres. I couldn't imagine that what should relate data together,
Yeah.
and it was so hard for me. I didn't do that again.
Yeah, this is important to design your schema so the data is accessed fastly.
My brain trained relational database, so maybe because of that, migration from Postgres to MongoDB is more harder than any. Definitely, it's harder than this.
Yeah, you need to transform your data to do this.
Do you think you can show some practical, maybe with that, something practical that you have done right now or no?
Right now, I guess no. I'm running on Windows.
You will share the presentation?
Yeah, of course, of course.